All right, guys, we're going to keep going here with our chapter on inequalities. And this first thing that we're going to talk about today are compound inequalities. So 3.6 I'm actually going to break into two sections because it's kind of a longer section, but you need to pause and make sure you write this down. It says a compound inequality consists of two distinct inequalities joined by the word and or the word or. Today we're going to be focusing on just the word and. Okay, the ones that have the word and in it, and then your next lesson will be the ones that have the word or. So here's a chart that I want to make sure that you copy down in here. So the way this works, these are what an and one looks like. So here if I have two inequalities, compound means more than one. Okay, so compound, two things that are put together. If I have x is greater than 3, it graphs like this. Notice it's a closed circle. It's going in this direction. If I have x is less than -7, or x is less than or equal to 7, that would graph like this. So when it's a compound inequality, you're looking at those things combined. So when x is greater than or equal to 3 and when x is less than or equal to 7. In other words, the ones that are in between here. Now when it's an and one, you could actually write this a special way in math where you have the first value, the smaller of the two, and then the second value, and then you put your variable in the middle and you use less than or equal to. Now these are both less than or equal to. And you could actually write the compound inequality this way. And this is the habit that I want you to get into writing these. Now this, if I covered this up right here and ignore this, and I'm looking here, this says x is less than or equal to 7. That's not any different. But this one, if I covered this up, you have to read that backwards. So where it says 3 is less than or equal to x, this says x is greater than or equal to 3, which is what we have. Over here, you want to go ahead and copy this down into your notes, even though I'm not going to be doing examples. Notice x is less than -2, so it's open circle going this way. X is greater than or equal to 1, it's going this way. There is no overlap. So the only way to write this is by writing two separate inequalities. The only way you could do this is when there is an overlap. That's the only time it makes sense. Okay, so again, we'll look at or a little bit later in another lesson. Today we are focusing on just this and part. Okay, so here is a math problem for you. Find x. Oh man, if only it were that easy. By the way, if you do this, I will count it wrong on any checkpoint, quiz, or test. Alright, so writing a compound inequality. It says write an inequality to model the situation, all real numbers that are greater than -2 and less than 6. So start out with your two inequalities. All real numbers that are greater than -2, and then all the ones that are less than 6. Well, think about what this is saying on a number line. I have -2 right here. I would have 6 right here. All the numbers that are greater than -2 are going to represent this way. All the ones that are less than that, it's going to be this way. So the way we could write this as a compound inequality would be -2 is less than x is less than 6. Now if you did write this not as two separate things, I wouldn't count it wrong, but this is a better way of writing it. That's my preference. All right, so all real numbers that are less than 0, so x is less than 0, or greater than or equal to 5. Now notice this has an or, so x is greater than or equal to 5. And if you think of this in the number line, I have 0 as my first number, and it says x is less than that, so that's all these. And then I have x is greater than or equal to 5, so that's a closed circle right here, and that's all of these values. Should always put arrows on the end of your number line. So this has no overlap, so the only way to write this is by using that word or. So you would say x is less than 0 or x is greater than or equal to 5. And you must have the word or it is incorrect. So be very, very careful with that. Okay, so you go ahead and take a second, pause, and try those. And when you're finished, check your answers against mine. The first one, hopefully you found that is -6. less than or equal to x less than or equal to 2. And then the second one, hopefully you found that x is less than negative 3 or x is greater than or equal to 3.5. So this one up here is an and this one down here is an or. And when you have the or ones, you must have the word or in there. All right, so how does this work in math? It says, what are the solutions? And then graph the solutions. So here, if you think of this, I have two separate problems. I have a less than or equal to, and then I have a less than. Well, you could kind of treat this as the same way you would with your properties of inequality. So whatever I do on one side, I have to do to the other. But in this case, I kind of have three sides. I have this side, and this side. If I want to isolate this variable, I would add 4. Now, properties of inequality would say that if I add 4 on this side, then I also have to add 4 on this side, so I'll do that. But because this time I have kind of like three sides, I'd also need to add 4 over here. Okay, so anytime there's this inequality sign, I have a new thing that's happening. So I would go through and do this. This is 1. Come on now. Less than or equal to. I'm left with m. Over here is a less than negative 1. Whoops, add 4. That'd be, check that. That'd be 3. Negative 1 plus 4 is 3. So here is my compound inequality. It says graph the solution. So I could have 0, 1, 2, 3, and 4, and we'll say that's good enough. This first one is closed circle, and m is all the values that are greater. It's an open circle here, so I just fill in all those values, and that's what that would look like graphed. So it's saying 1 or more all the way up to 3, but not including 3. All right, so here's one for you to try. Go ahead and take a moment and try that on your own. All right, so here is the answer, and hopefully for this first one you found this to be the case, and that should be something what your graph looks like. Now notice I wrote 2/3 over the top of this just to make sure that it is clear what value that is. All right, so here we have a word problem. It says to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you earn on the 4th and final test to earn a B? Well, in order to do this, you have to remember how to find an average. So to find an average, you take the sum of all the parts. So there's the sum of all my parts plus this unknown test score, and divide it by whatever that number is. So this represents the average of my tests. Here it says between 84 and 86 inclusive, meaning it includes those values. So I could have a test score that is greater than or equal to 84, even though that's that sign. Remember, I'm reading this right to left. And then less than or equal to 86 in order to get a B. So what test scores do I need? And then I go through and solve this. So the first thing here would be to multiply everything by 4. All right, so these cancel. And I am left with 336. And then I also need to add these values together. So I'm going to go ahead and do that and kind of combine a couple steps here. So that would be let's see, 80 times 3 is 240, plus those is going to be 251, plus x is less than or equal to, and this was 344. I need to subtract 251 from everything. And when I subtract 251 from this first one, I get 85. I'm kind of running out of room here, so I'll put it here. 85 less than or equal to, I have my x left, less than or equal to, and then 344 minus that is a 93. Okay, so as long as you get an 85 to a 93 on this particular question, then you will earn a B. So this is how you can actually use these compound inequalities to help you figure things out. This tells you what scores you need to get a B. Let's take a look at this. All right, so pause and you try this one on your own. And hopefully when you're done, you find that the answer is no. It is impossible for you to get a B because you cannot get over 100. You'd have to get somewhere between a 101 and a 109 is what I came up with. So those values are impossible for you if you can't get over 100. And I believe that's it for today. Yep, so that's only half the section. We'll do the other half in our next lesson. So come to class prepared to do some problems and a checkpoint. Have a good evening.